Okay, for the first part, it's asking find the tension T in the cable in the arrangement. So first, we have to see all the information we have. We have that the weight on the suspended weight, and we also have the weight of the strut, both are the same. Also, we have this tension on the horizontal direction that is going to the left, and also we have these two forces, and this is the vertical force and this is the horizontal force. Okay, so first we have that the sum of the forces for the y direction is equal to 0. So we have that the vertical direction we have FV positive and 2 negative W's. That if we simplify a little bit, we have this, and then FB equals 2W. So now also we have to find the sum of all the forces on the horizontal. So for the horizontal, we have Fx equals 0, and we have the FH in the positive and the negative tension right here. So we have that T equals FH. Now we have to find the sum of all the toric forces. So we have that the TL sine 30 is positive since it's going up, and then we have the W's which are negative times the other WL since going from this part cosine 30. So now we can cancel all the L's, and then we get T sine 30 minus W squared cosine 30 minus W cosine 30, and we can move this to the other side to make all of them positive. Alright, so now we can simplify all this. So we're gonna have T over 2, W over 2 times square root of 2 plus W square root of 2. If we keep simplifying, we have W square root of 3 over 2 plus W square root of 3, and T equals 3 times square root of 3 over 2W. So we have that T equals 2.6 W when we put this in the calculator. So now it's asking about find the magnitude of the forces exerted on the strut by the pivot and in the arrangement A. So in the problem we have right here. So in part B, we have to do the Pythagorean theory in order to find the magnitude. So we put our information that we already got, and we get 3.28 W, and also it's asking about the degree, the angles, sorry. So we have to put tan inverse 1 over 2W over 2.6 W, the W's cancel, and if you put that in the calculator, it's going to give you 37.6 degrees. And that's it. Okay, I draw a free body diagram showing all the forces acting on this system. So we got that two weights are pulling downwards right here. Also, we have that the force in the vertical direction is going up and the force in the horizontal direction is going to the right. Also, we got acting on the horizontal direction the T cosine 30 that is pulling upwards, and also we have this tension going to the left right here. So now we're gonna do the sum of all the forces in the x direction right here. So we got that 0 is equals to the force in the horizontal direction that is going to the right, and also the minus the T cosine 30 that is going to the left. So we got those, and we can say equal to each other. So that's going to be f of h equals T cosine 30 positive. Also, we're going to do the force in the y direction, the sum of all the forces in the y direction. So now we have that 0 is equal to force in the vertical direction minus 2w that they're pulling down, and minus the T sine 30. And we can set these equal to each other, and f of b equal to w plus T sine 30. And that's what we get for the sum of all the forces in the horizontal and the vertical direction. Now we have to do the forces in the sum of all the torques. So we have to identify what is going on, so what's pulling up or down. So we got that the T cosine 30 is positive times the distances right here. So it's L sine 45 minus T sine 30, and we also have the distance right here times L 40 cosine of 45 minus the weight times the distance that is right here of 45. So that, and also the other weight times its distance, that is this one right here, right here. So L cosine 45. So now we can cancel all the L's, and then we're gonna have T cosine 30 sine 45 equal T sine 30 cosine 45 plus 3w squared cosine 45. And we can divide all this by cosine 45 to cancel them. So since this one and this one gives you 1, we can cancel it, and this one and this one are the same, so we can cancel that as well. So we got T cosine 30 equals T sine 30 plus 3w over 2. So now we can move this to the other side, and also we can factor it. So that's going to give us T cosine 30 minus sine 30 equals 3w over 2, and we can get this 3W and divide this to the other side, and we got 2 cosine 30 minus sine 30, and that's gonna give us 4.10 W. That's gonna be the tension. So now we have our 4.10 W right here. So now we can solve we can plug the T in here and also in here, so we can know the forces that is acting on those. So for the force in the horizontal direction, we have 4.10 W cosine 30, and that's gonna give us 3.55 W. And for the force in the vertical direction, it's gonna give us 2 W plus 4.10 W sine of 30, and that's gonna give us 4.05 W. So now we can get the magnitude and also the angle. So the magnitude of the forces is gonna be 3.55 W squared plus 4.05 W squared, and that's gonna give us 5.39 W, and we have to find the angle as well. So we know that inverse tangent is gonna give us the angle, and 3.55 W. So we can cancel the W's, and we're gonna get 48.8 degrees. And that's it.